Bin definition inheritance. A bin definition can contain a lot of configuration information, including constructor arguments, property values, and container-specific information, such as the initialization method, a static factory method name, and so on. A child bin definition inherits configuration data from a parent definition. The child definition can override some values or add others as needed. Using parent and child bin definitions can save a lot of typing. Effectively, this is a form of templating. If you work with an application context interface programmatically, child bin definitions are represented by the child bin definition class. Most users do not work with them on this level. Instead, they configure bin definitions declaratively in a class such as the class path XML application context. When you use XML-based configuration metadata, you can indicate a child bin definition by using the parent attribute, specifying the parent bin as the value of this attribute. The following example shows how to do so. Less than, the age property value of 1 will be inherited from parent, greater than. A child bin definition uses the bin class from the parent definition if none is specified but can also override it. In the latter case, the child bin class must be compatible with the parent, that is, it must accept the parent's property values. A child bin definition inherits scope, constructor argument values, property values, and method overrides from the parent, with the option to add new values. Any scope, initialization method, destroy method, or static factory method settings that you specify override the corresponding parent settings. The remaining settings are always taken from the child definition, depends on, auto-wire mode, dependency check, singleton, and lazy init. The preceding example explicitly marks the parent bin definition as abstract by using the abstract attribute. If the parent definition does not specify a class, explicitly marking the parent bin definition as abstract is required, as the following example shows. Less than, age will inherit the value of 1 from the parent bin definition greater than. The parent bin cannot be instantiated on its own because it is incomplete, and it is also explicitly marked as abstract. When a definition is abstract, it is usable only as a pure template bin definition that serves as a parent definition for child definitions. Trying to use such an abstract parent bin on its own, by referring to it as a ref property of another bin or doing an explicit get bin call with the parent bin ID returns an error. Similarly, the container's internal pre-instantiate singletons method ignores bin definitions that are defined as abstract. Application context pre-instantiates all singletons by default. Therefore, it is important, at least for singleton beans, that if you have a parent bin definition which you intend to use only as a template, and this definition specifies a class, you must make sure to set the abstract attribute to true, otherwise the application context will actually attempt to pre-instantiate the abstract bin. Container extension points. Typically, an application developer does not need to subclass application context implementation classes. Instead, the Spring IoC Container can be extended by plugging in implementations of special integration interfaces. The next few sections describe these integration interfaces. Customizing beans by using a bin post processor. The bin post processor interface defines callback methods that you can implement to provide your own, or override the container's default, instantiation logic, dependency resolution logic, and so forth. If you want to implement some custom logic after the Spring Container finishes instantiating, configuring, and initializing a bin, you can plug in one or more custom bin post processor implementations. You can configure multiple bin post processor instances, and you can control the order in which these bin post processor instances run by setting the order property. You can set this property only if the bin post processor implements the ordered interface. If you write your own bin post processor, you should consider implementing the ordered interface, too. For further details, see the Java doc of the bin post processor and ordered interfaces. See also the note on programmatic registration of bin post processor instances. Bin post processor instances operate on bin, or object, instances. That is, The Spring IoC container instantiates a bin instance and then bin post-processor instances do their work. Bin post-processor instances are scoped per container. This is relevant only if you use container hierarchies. If you define a bin post-processor in one container, it post-processes only the beans in that container. In other words, beans that are defined in one container are not post-processed by a bin post-processor defined in another container, even if both containers are part of the same hierarchy. To change the actual bin definition, that is, the blueprint that defines the bean, you instead need to use a bin factory post-processor, as described in customizing configuration metadata with a bin factory post processor. The org.springframework.beans.factory.config.bin post-processor interface consists of exactly two callback methods. When such a class is registered as a post-processor with the container, for each bin instance that is created by the container, the post-processor gets a callback from the container both before container initialization methods, such as initializing bin.after properties set or any declared init method, are called, and after any bin initialization callbacks. The post-processor can take any action with the bin instance, including ignoring the callback completely. A bin post-processor typically checks the callback interfaces, or it may wrap a bin with a proxy. Some Spring AOP infrastructure classes are implemented as bin post-processors in order to provide proxy wrapping logic. An application context automatically detects any beans that are defined in the configuration metadata that implement the bin post-processor interface. The application context registers these beans as post-processors so that they can be called later, upon bin creation. Bin post-processors can be deployed in the container in the same fashion as any other beans. Note that, when declaring a bin post-processor by using an bin factory method on a configuration class, the return type of the factory method should be the implementation class itself or at least the org.springframework.beans.factory.config.bin post-processor interface, clearly indicating the post-processor nature of that bin. Otherwise, the application context cannot auto-detect it by type before fully creating it. Since a bin post-processor needs to be instantiated early in order to apply to the initialization of other beans in the context, this early type detection is critical. Programmatically registering bin post-processor instances. While the recommended approach for bin post-processor registration is through application context auto-detection, as described earlier, you can register them programmatically against a configurable bin factory by using the add bin post-processor method. This can be useful when you need to evaluate conditional logic before registration or even for copying bin post-processors across contexts in a hierarchy. Note, however, that bin post-processor instances added programmatically do not respect the ordered interface. Here, it is the order of registration that dictates the order of execution. Note also that bin post-processor instances registered programmatically are always processed before those registered through auto-detection, regardless of any explicit ordering. Classes that implement the bin post-processor interface are special and are treated differently by the container. All bin post-processor instances and beans that they directly reference are instantiated on startup, as part of the special startup phase of the application context. Next, all bin post-processor instances are registered in a sorted fashion and applied to all further beans in the container. Because AOP auto-proxying is implemented as a bin post-processor itself, neither bin post-processor instances nor the beans they directly reference are eligible for auto-proxying and, thus, do not have aspects woven into them. For any such bin, you should see an informational log message, bean some bin is not eligible for getting processed by all bin post-processor interfaces, for example, not eligible for auto-proxying. If you have beans wired into your bin post-processor by using auto-wiring or at resource, which may fall back to auto-wiring, Spring might access unexpected beans when searching for type-matching dependency candidates and, therefore, make them ineligible for auto-proxying or other kinds of bin post-processing. For example, if you have a dependency annotated with at resource where the field or setter name does not directly correspond to the declared name of a bin and no name attribute is used, Spring accesses other beans for matching them by type. The following examples show how to write, register, and use bin post-processor instances in an application context. Example, Hello World, bin post-processor style. This first example illustrates basic usage. The example shows a custom bin post-processor implementation that invokes the toString method of each bin as it is created by the container and prints the resulting string to the system console. The following listing shows the custom bin post-processor implementation class definition. Import org.springframework.beans.factory.config.bin post processor. Public class instantiation tracing bin post-processor implements bin post processor. / simply return the instantiated bin as is. Public object post-process before initialization object bin, string bin name. Return bin, / we could potentially return any object reference here. Public object post-process after initialization object bin, string bin name. System.out.println bin plus bin name plus created, plus bin.toString, return bin. The following beans element uses the instantiation, tracing, bin, post, processor. HTTP URL. HTTP URL. HTTP URL. HTTP URL. Classpath org/springframework/scripting/groovy/messenger.groovy. Less than dash when the above bin, messenger, is instantiated, this custom bin post-processor implementation will output the fact to the system console. Dash greater than. Notice how the instantiation tracing bin post-processor is merely defined. It does not even have a name, and, because it is a bin, it can be dependency injected as you would any other bin. The preceding configuration also defines a bin that is backed by a Groovy script. The Spring Dynamic Language Support is detailed in the chapter entitled Dynamic Language Support. The following Java application runs the preceding code and configuration. Import org.springframework.context.application context, import org.springframework.context.support.classpath XML application context, import org.springframework.scripting.messenger. Public final class boot. Public static void main final string, args, throws exception, application context ctx equals new class path XML application context scripting /beans.xml, messenger equals ctx.getBin messenger.class, system.out.println messenger. The output of the preceding application resembles the following. Bin messenger created, org.springframework.scripting.groovy messenger at 272961. org.springframework.scripting.groovy messenger at 272961. Example, the auto-wired annotation bin post-processor, using callback interfaces or annotations in conjunction with a custom bin post-processor implementation is a common means of extending the Spring IoC container. An example is Spring's auto-wired annotation bin post-processor, a bin post-processor implementation that ships with the Spring distribution and auto-wires annotated fields, setter methods, and arbitrary config methods. Customizing configuration metadata with a bin factory post-processor. The next extension point that we look at is the org.springframework.beans.factory.config.bin factory post-processor. The semantics of this interface are similar to those of the bin post-processor, with one major difference: bin factory post-processor operates on the bin configuration metadata. That is, the Spring IoC container lets a bin factory post-processor read the configuration metadata and potentially change it before the container instantiates any beans other than bin factory post-processor instances. You can configure multiple bin factory post-processor instances, and you can control the order in which these bin factory post-processor instances run by setting the order property. However, you can only set this property if the bin factory post-processor implements the ordered interface. If you write your own bin factory post-processor, you should consider implementing the ordered interface, too. See the Java doc of the bin factory post-processor and ordered interfaces for more details. If you want to change the actual bin instances, that is, the objects that are created from the configuration metadata, then you instead need to use a bin post-processor, described earlier in customizing beans by using a bin post-processor. While it is technically possible to work with bin instances within a bin factory post-processor, for example, by using binfactory.getBin, doing so causes premature bin instantiation, violating the standard container lifecycle. This may cause negative side effects, such as bypassing bin post-processing. Also, bin factory post-processor instances are scoped per container. This is only relevant if you use container hierarchies. If you define a bin factory post-processor in one container, it is applied only to the bin definitions in that container. Bin definitions in one container are not post-processed by bin factory post-processor instances in another container, even if both containers are part of the same hierarchy. A bin factory post-processor is automatically run when it is declared inside an application context, in order to apply changes to the configuration metadata that define the container. Spring includes a number of predefined bin factory post-processors, such as property override configurer and property sources placeholder configurer. You can also use a custom bin factory post-processor, for example, to register custom property editors. An application context automatically detects any beans that are deployed into it that implement the bin factory post-processor interface. It uses these beans as bin factory post-processors at the appropriate time. You can deploy these post-processor beans as you would any other bean. As with bin post-processors, you typically do not want to configure bin factory post-processors for lazy initialization. If no other bin references a bin factory post-processor, that post-processor will not get instantiated at all. Thus, marking it for lazy initialization will be ignored, and the bin factory post-processor will be instantiated eagerly even if you set the default lazy init attribute to true on the declaration of your beans, greater than element. Example, the class name substitution property sources placeholder configurer. You can use the property sources placeholder configurer to externalize property values from a bin definition in a separate file by using the standard Java properties format. Doing so enables the person deploying an application to customize environment-specific properties, such as database URLs and passwords, without the complexity or risk of modifying the main XML definition file or files for the container. Consider the following XML-based configuration metadata fragment, where a data source with placeholder values is defined. org.springframework.context.support.property. Sources, placeholder, configurer. The example shows properties configured from an external properties file. At runtime, a property sources placeholder configurer is applied to the metadata that replaces some properties of the data source. The values to replace are specified as placeholders of the form $property name, which follows the ant and log4j and JSPL style. The actual values come from another file in the standard Java properties format. jdbc.driver class name equals org.hsqldb.jdbcdriver. jdbc.url equals jdbc/hsqldb/production:9002. jdbc.username equals sar. jdbc.password equals root. Therefore, the $jdbc.username string is replaced at runtime with the value sar, and the same applies for other placeholder values that match keys in the properties file. The property sources placeholder configurer checks for placeholders in most properties and attributes of a bin definition. Furthermore, you can customize the placeholder prefix and suffix. With the context namespace introduced in Spring 2.5, you can configure property placeholders with a dedicated configuration element. You can provide one or more locations as a comma-separated list in the location attribute, as the following example shows. The property sources placeholder configurer not only looks for properties in the properties file you specify. By default, if it cannot find a property in the specified properties files, it checks against Spring environment properties and regular Java system properties. You can use the property sources placeholder configurer to substitute class names, which is sometimes useful when you have to pick a particular implementation class at runtime. The following example shows how to do so. bin class equals org.springframework.beans.factory.config.property sources placeholder configurer greater than property name equals locations greater than value class bath.com /something /strategy.properties /value /property name equals properties greater than value custom.strategy.class equals com.something.default strategy /value /property /bin. bin.i.d. equals service strategy class equals $custom.strategy.class, greater than. If the class cannot be resolved at runtime to a valid class, resolution of the bin fails when it is about to be created, which is during the pre-instantiate singletons phase of an application context for a non-lazy init bin. Example, the property override configurer. The property override configurer, another bin factory post-processor, resembles the property sources placeholder configurer, but unlike the latter, the original definitions can have default values or no values at all for bin properties. If an overriding properties file does not have an entry for a certain bin property, the default context definition is used. Note that the bin definition is not aware of being overridden, so it is not immediately obvious from the XML definition file that the override configurer is being used. In case of multiple property override configurer instances that define different values for the same bin property, the last one wins, due to the overriding mechanism. Properties file configuration lines take the following format. The following listing shows an example of the format. Data source.driver class name equals com.mysql.jdbc.driver. Data source.url equals jdbc mysql mid. This example file can be used with a container definition that contains a bin called data source that has driver and URL properties. Compound property names are also supported, as long as every component of the path except the final property being overridden is already non-null, presumably initialized by the constructors. In the following example, the Sammy property of the Bob property of the Fred property of the Tom bin is set to the scalar value 123. Specified override values are always literal values. They are not translated into bin references. This convention also applies when the original value in the XML bin definition specifies a bin reference. With the context namespace introduced in Spring 2.5, it is possible to configure property overriding with a dedicated configuration element, as the following example shows. Customizing instantiation logic with a factory bin. You can implement the org.springframework.beans.factory.factory bin interface for objects that are themselves factories. The factory bin interface is a point of pluggability into the Spring IoC Containers instantiation logic. If you have complex initialization code that is better expressed in Java as opposed to a, potentially, verbose amount of XML, you can create your own factory bin, write the complex initialization inside that class, and then plug your custom factory bin into the container. The factory bin >t interface provides three methods. 1. tGetObject returns an instance of the object this factory creates. The instance can possibly be shared, depending on whether this factory returns singletons or prototypes. 2. Boolean is singleton, returns true if this factory bin returns singletons or false otherwise. The default implementation of this method returns true. 3. Class less than greater than getObjectType returns the object type returned by the getObject method or null if the type is not known in advance. The factory bin concept and interface are used in a number of places within the Spring framework. More than 50 implementations of the factory bin interface ship with Spring itself. When you need to ask a container for an actual factory bin instance itself instead of the bin it produces, prefix the bin's ID with the ampersand symbol, and, when calling the getBin method of the application context. So, for a given factory bin with an ID of myBin, invoking getBin myBin, on the container returns the product of the factory bin, whereas invoking getBin and myBin, returns the factory bin instance itself. Annotation-based container configuration. Are annotations better than XML for configuring Spring? The introduction of annotation-based configuration raised the question of whether this approach is better than XML. The short answer is it depends. The long answer is that each approach has its pros and cons, and, usually, it is up to the developer to decide which strategy suits them better. Due to the way they are defined, annotations provide a lot of context in their declaration, leading to shorter and more concise configuration. However, XML excels at wiring up components without touching their source code or recompiling them. Some developers prefer having the wiring close to the source, while others argue that annotated classes are no longer POJOs and, furthermore, that the configuration becomes decentralized and harder to control. No matter the choice, Spring can accommodate both styles and even mix them together. It is worth pointing out that through its Java config option, Spring lets annotations be used in a non-invasive way, without touching the target component's source code, and that, in terms of tooling, all configuration styles are supported by Spring tools for Eclipse, Visual Studio Code, and Thea. An alternative to XML setup is provided by annotation-based configuration, which relies on bytecode metadata for wiring up components instead of XML declarations. Instead of using XML to describe a bin wiring, the developer moves the configuration into the component class itself by using annotations on the relevant class, method, or field declaration. As mentioned in example, the auto-wired annotation bin post processor, using a bin post processor in conjunction with annotations is a common means of extending the Spring IoC container. For example, the auto-wired annotation provides the same capabilities as described in auto-wiring collaborators, but with more fine-grained control and wider applicability. In addition, Spring provides support for JSR 250 annotations, such as at post-construct and at pre-destroy, as well as support for JSR 330, dependency injection for Java, annotations contained in the Jakarta.inject package such as at inject and at named. Details about those annotations can be found in the relevant section. Annotation injection is performed before XML injection. Thus, the XML configuration overrides the annotations for properties wired through both approaches. As always, you can register the post processors as individual bin definitions, but they can also be implicitly registered by including the following tag in an XML-based Spring configuration. Notice the inclusion of the context namespace. HTTP URL. HTTP URL. HTTP URL. HTTP URL. The context annotation config element implicitly registers the following post processors. Context annotation config only looks for annotations on beans in the same application context in which it is defined. This means that, if you put context annotation config in a web application context for a dispatcher servlet, it only checks for auto-wired beans in your controllers, and not your services. See the dispatcher servlet for more information. Using auto-wired. JSR 330's inject annotation can be used in place of Spring's auto-wired annotation in the examples included in this section. See here for more details. You can apply the auto-wired annotation to constructors, as the following example shows. Public class movie recommender. Private final customer preference DAO customer preference DAO. Auto-wired. Public movie recommender customer preference DAO. This customer preference DAO equals customer preference DAO. // As of Spring Framework 4.3, an auto-wired annotation on such a constructor is no longer necessary if the target bin defines only one constructor to begin with. However, if several constructors are available and there is no primary/default constructor, at least one of the constructors must be annotated with auto-wired in order to instruct the container which one to use. See the discussion on constructor resolution for details. You can also apply the auto-wired annotation to traditional setter methods, as the following example shows. Public class simple movie lister. Private movie finder auto-wired. Public void set movie finder. This movie finder equals movie finder. // You can also apply the annotation to methods with arbitrary names and multiple arguments, as the following example shows. Public class movie, recommender. Private movie catalog, private customer preference DAO, customer preference DAO. At AutoWired. Public void prepare movie catalog, customer preference DAO. This.movie catalog equals movie catalog, this.customer preference DAO equals customer preference DAO. // You can apply at AutoWired to fields as well and even mix it with constructors, as the following example shows. Public class movie, recommender. Private final customer preference DAO, customer preference DAO. At AutoWired. Private movie catalog, at AutoWired. Public movie recommender customer preference DAO. This.customer preference DAO equals customer preference DAO. // Make sure that your target components, for example, movie catalog or customer preference DAO, are consistently declared by the type that you use for your at AutoWired annotated injection points. Otherwise, injection may fail due to a no-type match found error at runtime. For XML-defined beans or component classes found via class path scanning, the container usually knows the concrete type up front. However, for at-bin factory methods, you need to make sure that the declared return type is sufficiently expressive. For components that implement several interfaces or for components potentially referred to by their implementation type, consider declaring the most specific return type on your factory method, at least as specific as required by the injection points referring to your bin. You can also instruct Spring to provide all beans of a particular type from the application context by adding the at AutoWired annotation to a field or method that expects an array of that type, as the following example shows. Public class movie, recommender. At AutoWired. Private movie catalog, catalogs. // The same applies for typed collections, as the following example shows. Public class movie, recommender. Private set movie catalog, catalogs. At AutoWired. Public void set movie catalogs, catalogs. This.movie catalogs equals movie catalogs. // Your target beans can implement the org.springframework.core.ordered interface or use the at order or standard at priority annotation if you want items in the array or list to be sorted in a specific order. Otherwise, their order follows the registration order of the corresponding target bin definitions in the container. You can declare the at order annotation at the target class level and on at bin methods, potentially for individual bin definitions, in case of multiple definitions that use the same bin class. At order values may influence priorities at injection points, but be aware that they do not influence singleton startup order, which is an orthogonal concern determined by dependency relationships and it depends on declarations. Note that the standard Jakarta.annotation.priority annotation is not available at the at-bin level, since it cannot be declared on methods. Its semantics can be modeled through at order values in combination with at primary on a single bin for each type. Even typed map instances can be auto-wired as long as the expected key type is string. The map values contain all beans of the expected type, and the keys contain the corresponding bin names, as the following example shows. Public class movie, recommender. Private map string, movie catalog, catalogs. At AutoWired. Public void set movie catalogs map string, movie catalogs. This.movie catalogs equals movie catalogs. // By default, auto-wiring fails when no matching candidate beans are available for a given injection point. In the case of a declared array, collection, or map, at least one matching element is expected. The default behavior is to treat annotated methods and fields as indicating required dependencies. You can change this behavior as demonstrated in the following example, enabling the framework to skip a non-satisfiable injection point through marking it as non-required, i.e., by setting the required attribute in at AutoWired to false. Public class simple, movie, lister. Private movie finder. At AutoWired required equals false, public void set movie finder. This movie finder equals movie finder. / A non-required method will not be called at all if its dependency, or one of its dependencies, in case of multiple arguments, is not available. A non-required field will not get populated at all in such cases, leaving its default value in place. In other words, setting the required attribute to false indicates that the corresponding property is optional for auto-wiring purposes, and the property will be ignored if it cannot be auto-wired. This allows properties to be assigned default values that can be optionally overridden via dependency injection. Injected constructor and factory method arguments are a special case since the required attribute in at AutoWired has a somewhat different meaning due to Spring's constructor resolution algorithm that may potentially deal with multiple constructors. Constructor and factory method arguments are effectively required by default but with a few special rules in a single constructor scenario, such as multi-element injection points, arrays, collections, maps, resolving to empty instances if no matching beans are available. This allows for a common implementation pattern where all dependencies can be declared in a unique multi-argument constructor, for example, declared as a single public constructor without an at AutoWired annotation. Only one constructor of any given bin class may declare at AutoWired with the required attribute set to true, indicating the constructor to AutoWire when used as a Spring bin. As a consequence, if the required attribute is left at its default value true, only a single constructor may be annotated with at AutoWired. If multiple constructors declare the annotation, they will all have to declare required equals false in order to be considered as candidates for auto-wiring, analogous to AutoWire equals constructor in XML. The constructor with the greatest number of dependencies that can be satisfied by matching beans in the Spring container will be chosen. If none of the candidates can be satisfied, then a primary/default constructor, if present, will be used. Similarly, if a class declares multiple constructors but none of them is annotated with at AutoWired, then a primary/default constructor, if present, will be used. If a class only declares a single constructor to begin with, it will always be used, even if not annotated. Note that an annotated constructor does not have to be public. Alternatively, you can express the non-required nature of a particular dependency through Java 8's java.util.optional, as the following example shows. Public class simple, movie, lister. At AutoWired. Public void set movie finder optional movie finder. As of Spring Framework 5.0, you can also use a at nullable annotation of any kind in any package, for example, javax.annotation.nullable from JSR 305, or just leverage Kotlin built-in null safety support. Public class simple, movie, lister. At AutoWired. Public void set movie finder at nullable movie finder. You can also use at AutoWired for interfaces that are well-known resolvable dependencies, being factory, application context, environment, resource loader, application event publisher, and message source. These interfaces and their extended interfaces, such as configurable application context or resource pattern resolver, are automatically resolved, with no special setup necessary. The following example auto-wires an application context object. Public class movie, recommender. At AutoWired. Private application context. Public movie, recommender. / The at AutoWired, at inject, at value, and at resource annotations are handled by Spring bin post-processor implementations. This means that you cannot apply these annotations within your own bin post-processor or bin factory post-processor types, if any. These types must be wired up explicitly by using XML or a Spring at bin method. Fine-tuning annotation-based auto-wiring with at primary. Because auto-wiring by type may lead to multiple candidates, it is often necessary to have more control over the selection process. One way to accomplish this is with springs at primary annotation. At primary indicates that a particular bin should be given preference when multiple beans are candidates to be auto-wired to a single valued dependency. If exactly one primary bin exists among the candidates, it becomes the auto-wired value. Consider the following configuration that defines first movie catalog as the primary movie catalog. At configuration. Public class movie configuration. At bin. At primary. Public movie catalog first movie catalog, at bin. Public movie catalog second movie catalog, // With the preceding configuration, the following movie recommender is auto-wired with the first movie catalog. Public class movie recommender. At auto-wired. Private movie catalog // http URL http URL http URL http URL less than inject any dependencies required by this bin greater than less than inject any dependencies required by this bin greater than. Fine-tuning annotation-based auto-wiring with qualifiers at primary is an effective way to use auto-wiring by type with several instances when one primary candidate can be determined. When you need more control over the selection process, you can use springs at qualifier annotation. You can associate qualifier values with specific arguments, narrowing the set of type matches so that a specific bin is chosen for each argument. In the simplest case, this can be a plain descriptive value, as shown in the following example. Public class movie recommender. At auto-wired. At qualifier main, private movie catalog // You can also specify the at qualifier annotation on individual constructor arguments or method parameters, as shown in the following example. Public class movie recommender. Private final movie catalog Private final customer preference DAO customer preference DAO. At auto-wired. Public void prepare at qualifier main movie catalog customer preference DAO. This dot movie catalog equals movie catalog. This dot customer preference DAO equals customer preference DAO // The following example shows corresponding bin definitions. http URL http URL http URL http URL less than inject any dependencies required by this bin greater than less than inject any dependencies required by this bin greater than. The bin with the main qualifier value is wired with the constructor argument that is qualified with the same value. The bin with the action qualifier value is wired with the constructor argument that is qualified with the same value. For a fallback match, the bin name is considered a default qualifier value. Thus, you can define the bin with an ID of main instead of the nested qualifier element, leading to the same matching result. However, although you can use this convention to refer to specific beans by name, at auto-wired is fundamentally about type-driven injection with optional semantic qualifiers. This means that qualifier values, even with the bin name fallback, always have narrowing semantics within the set of type matches. They do not semantically express a reference to a unique bin ID. Good qualifier values are main or emir or persistent, expressing characteristics of a specific component that are independent from the bin ID, which may be auto-generated in case of an anonymous bin definition such as the one in the preceding example. Qualifiers also apply to typed collections, as discussed earlier. For example, to set movie catalog in this case, all matching beans, according to the declared qualifiers, are injected as a collection. This implies that qualifiers do not have to be unique. Rather, they constitute filtering criteria. For example, you can define multiple movie catalog beans with the same qualifier value action, all of which are injected into a set movie catalog annotated with at qualifier action. Letting qualifier values select against target bin names within the type matching candidates does not require a qualifier annotation at the injection point. If there is no other resolution indicator, such as a qualifier or a primary marker, for a non-unique dependency situation, Spring matches the injection point name, that is, the field name or parameter name, against the target bin names and chooses the same named candidate, if any. That said, if you intend to express annotation-driven injection by name, do not primarily use at auto-wired, even if it is capable of selecting by bin name among type matching candidates. Instead, use the JSR 250 at resource annotation, which is semantically defined to identify a specific target component by its unique name, with the declared type being irrelevant for the matching process. At auto-wired has rather different semantics. After selecting candidate beans by type, the specified string qualifier value is considered within those type-selected candidates only, for example, matching an account qualifier against beans marked with the same qualifier label. For beans that are themselves defined as a collection, map, or array type, at resource is a fine solution, referring to the specific collection or array bin by unique name. That said, as a 4.3, you can match collection, map, and array types through Spring's at auto-wired type matching algorithm as well, as long as the element type information is preserved in it bin return type signatures or collection inheritance hierarchies. In this case, you can use qualifier values to select among same-typed collections, as outlined in the previous paragraph. As a 4.3, at auto-wired also considers self-references for injection, that is, references back to the bin that is currently injected. Note that self-injection is a fallback. Regular dependencies on other components always have precedence. In that sense, self-references do not participate in regular candidate selection and are therefore in particular never primary. On the contrary, they always end up as lowest precedence. In practice, you should use self-references as a last resort only, for example, for calling other methods on the same instance through the beans transactional proxy. Consider factoring out the affected methods to a separate delegate bin in such a scenario. Alternatively, you can use at resource, which may obtain a proxy back to the current bin by its unique name. Trying to inject the results from at bin methods on the same configuration class is effectively a self-reference scenario as well. Either lazily resolve such references in the method's signature where it is actually needed, as opposed to an auto-wired field in the configuration class, or declare the affected at bin methods as static, decoupling them from the containing configuration class instance and its lifecycle. Otherwise, such beans are only considered in the fallback phase, with matching beans on other configuration classes selected as primary candidates instead, if available. At auto-wired applies to fields, constructors, and multi-argument methods, allowing for narrowing through qualifier annotations at the parameter level. In contrast, at resource is supported only for fields and bin property setter methods with a single argument. As a consequence, you should stick with qualifiers if your injection target is a constructor or a multi-argument method. You can create your own custom qualifier annotations. To do so, define an annotation and provide the qualifier annotation within your definition, as the following example shows. At target element type.field, element type.parameter, at retention policy.runtime at qualifier. Public at interface genre. String value. Then you can provide the custom qualifier on auto-wired fields and parameters, as the following example shows. Public class movie, recommender. At auto-wired. At genre action, private movie catalog action, catalog. Private movie catalog comedy, catalog. At auto-wired. Public void set comedy catalog at genre comedy, movie catalog comedy catalog. This.comedy catalog equals comedy, catalog. // Next, you can provide the information for the candidate bin definitions. You can add qualifier tags as sub-elements of the bin tag and then specify the type and value to match your custom qualifier annotations. The type is matched against the fully qualified class name of the annotation. Alternately, as a convenience if no risk of conflicting names exists, you can use the short class name. The following example demonstrates both approaches. HTTP URL http URL, http URL, http URL. Less than, inject any dependencies required by this bin, greater than. Less than, inject any dependencies required by this bin, greater than. In ClassPath scanning and managed components, you can see an annotation-based alternative to providing the qualifier metadata in XML. Specifically, see providing qualifier metadata with annotations. In some cases, using an annotation without a value may suffice. This can be useful when the annotation serves a more generic purpose and can be applied across several different types of dependencies. For example, you may provide an offline catalog that can be searched when no internet connection is available. First, define the simple annotation, as the following example shows. At target element type.field, element type.parameter, at retention policy.runtime at qualifier. Public at interface offline. Then add the annotation to the field or property to be auto-wired, as shown in the following example. Public class movie, recommender. At auto-wired. At offline. Private movie catalog offline, catalog. // Now the bin definition only needs a qualifier type, as shown in the following example. Less than, inject any dependencies required by this bin, greater than. You can also define custom qualifier annotations that accept named attributes in addition to or instead of the simple value attribute. If multiple attribute values are then specified on a field or parameter to be auto-wired, a bin definition must match all such attribute values to be considered an auto-wire candidate. As an example, consider the following annotation definition. At target element type.field, element type.parameter, at retention policy.runtime at qualifier. Public at interface movie, qualifier. String genre. Format. In this case format is an enum, defined as follows. The fields to be auto-wired are annotated with the custom qualifier and include values for both attributes, genre and format, as the following example shows. Public class movie, recommender. At auto-wired. At movie qualifier format equals format.vhs, genre equals action, private movie catalog action, VHS, catalog. At auto-wired. At movie qualifier format equals format.vhs, genre equals comedy, private movie catalog comedy, VHS, catalog. At auto-wired. At movie qualifier format equals format.dvd, genre equals action, private movie catalog action, DVD, catalog. At auto-wired. At movie qualifier format equals format.blu-ray, genre equals comedy, private movie catalog comedy, Blu-ray, catalog. // Finally, the bin definitions should contain matching qualifier values. This example also demonstrates that you can use bin meta-attributes instead of the qualifier elements. If available, the qualifier element and its attributes take precedence, but the auto-wiring mechanism falls back on the values provided within the meta tags if no such qualifier is present, as in the last two bin definitions in the following example. http URL, http URL, http URL, http URL. Less than, inject any dependencies required by this bin, greater than. Less than, inject any dependencies required by this bin, greater than. Less than, inject any dependencies required by this bin, greater than. Less than, inject any dependencies required by this bin, greater than. Using generics as auto-wiring qualifiers. In addition to the @qualifier annotation, you can use Java generic types as an implicit form of qualification. For example, suppose you have the following configuration. At configuration. Public class my, configuration. At bin. Public string store, return new string, store. At bin. Public integer store, return new integer, store. Assuming that the preceding beans implement a generic interface, that is, store string and store integer. You cannot auto-wire the store interface, and the generic is used as a qualifier, as the following example shows. At auto-wired, private store string s1 / string qualifier injects the string store bin. At auto-wired, private store integer s2 / integer qualifier injects the integer store bin. Generic qualifiers also apply when auto-wiring lists, map instances and arrays. The following example auto-wires a generic list. / inject all store beans as long as they have an integer generic. / store string beans will not appear in this list. At auto-wired, private list store integer s. Using Custom Auto-Wire Configurer. Custom Auto-Wire Configurer is a bin factory post-processor that lets you register your own custom qualifier annotation types, even if they are not annotated with Spring's add qualifier annotation. The following example shows how to use Custom Auto-Wire Configurer. bin.i.d. equals custom auto-wire configurer class equals org.springframework.beans.factory.annotation.custom auto-wire configurer greater than property name equals custom qualifier types greater than set value example.custom qualifier /value /set /property /bin. The auto-wire candidate resolver determines auto-wire candidates by 1. The auto-wire candidate value of each bin definition. 2. Any default auto-wire candidates patterns available on the beans element. 3. The presence of at qualifier annotations and any custom annotations registered with the custom auto-wire configurer. When multiple beans qualify as auto-wire candidates, the determination of a primary is as follows: if exactly one bin definition among the candidates has a primary attribute set to true, it is selected. Injection with at resource. Spring also supports injection by using the JSR 250 at resource annotation, Jakarta.annotation.resource, on fields or bin property setter methods. This is a common pattern in Jakarta EE, for example, in JSF managed beans and JAX WS endpoints. Spring supports this pattern for Spring managed objects as well. At resource takes a name attribute. By default, Spring interprets that value as the bin name to be injected. In other words, it follows by name semantics, as demonstrated in the following example. Public class simple, movie, lister. Private movie finder. At resource name equals my movie finder, public void set movie finder. This movie finder equals movie finder. If no name is explicitly specified, the default name is derived from the field name or setter method. In case of a field, it takes the field name. In case of a setter method, it takes the bin property name. The following example is going to have the bin named movie finder injected into its setter method. Public class simple, movie, lister. Private movie finder. At resource, public void set movie finder. This movie finder equals movie finder. The name provided with the annotation is resolved as a bin name by the application context of which the common annotation bin post-processor is aware. The names can be resolved through JNDI if you configure Spring's simple JND bin factory explicitly. However, we recommend that you rely on the default behavior and use Spring's JNDI lookup capabilities to preserve the level of indirection. In the exclusive case of at-resource usage with no explicit name specified, and similar to at auto-wired, at-resource finds a primary type match instead of a specific named bin and resolves well-known resolvable dependencies, the bin factory, application context, resource loader, application event publisher, and message source interfaces. Thus, in the following example, the customer preference DAO field first looks for a bin named customer preference DAO and then falls back to a primary type match for the type customer preference DAO. Public class movie recommender. At resource, private customer preference DAO customer preference, DAO. At resource, private application context, public movie, recommender, // The context field is injected based on the known resolvable dependency type, application context. Using @value. @value is typically used to inject externalized properties. @component. Public class movie, recommender. Private final string catalog. Public movie recommender @value $catalog.name, string catalog. This .catalog equals catalog. @configuration. @property source class path application.properties, public class app config. In that case, the catalog parameter and field will be equal to the movie catalog value. A default lenient embedded value resolver is provided by Spring. It will try to resolve the property value, and if it cannot be resolved, the property name, for example $catalog.name, will be injected as the value. If you want to maintain strict control over non-existent values, you should declare a property sources placeholder configure bin, as the following example shows. @configuration. Public class app, config. @bin. Public static property sources placeholder configure property placeholder configurer, return new property. Sources, placeholder, configurer. When configuring a property sources placeholder configurer using Java config, the @bin method must be static. Using the above configuration ensures Spring initialization failure if any $placeholder could not be resolved. It is also possible to use methods like setPlaceholder prefix, setPlaceholder suffix, or setValue separator to customize placeholders. Spring Boot configures by default a property sources placeholder configurer bin that will get properties from application.properties and application.yml files. Built-in converter support provided by Spring allows simple type conversion, to integer or int for example, to be automatically handled. Multiple comma-separated values can be automatically converted to string array without extra effort. It is possible to provide a default value as following. @component. Public class movie, recommender. Private final string catalog. Public movie recommender @value $catalog.name default catalog, string catalog. This .catalog equals catalog. A Spring Bin post-processor uses a conversion service behind the scenes to handle the process for converting the string value in @value to the target type. If you want to provide conversion support for your own custom type, you can provide your own conversion service bin instance, as the following example shows. @configuration. Public class app, config. @bin. Public conversion service default formatting conversion service equals new default formatting conversion service .add converter new my custom converter, return conversion service. When @value contains a SPL expression, the value will be dynamically computed at runtime as the following example shows. @component. Public class movie, recommender. Private final string catalog. Public movie recommender @value #system properties user.catalog plus catalog, string catalog. This .catalog equals catalog. SPL also enables the use of more complex data structures. @component. Public class movie, recommender. Private final map string, integer count, of movies, per catalog. Public movie recommender @value #thriller, 100, comedy, 300, map string, integer count of movies per catalog. This .count of movies per catalog equals count of movies per catalog. Using @post construct and @pre-destroy. The common annotation bin post processor not only recognizes the @resource annotation but also the JSR 250 lifecycle annotations, Jakarta.annotation.postConstruct and Jakarta.annotation.predestroy. Introduced in Spring 2.5, the support for these annotations offers an alternative to the lifecycle callback mechanism described in initialization callbacks and destruction callbacks. Provided that the common annotation bin post-processor is registered within the Spring application context, a method carrying one of these annotations is invoked at the same point in the lifecycle as the corresponding Spring lifecycle interface method or explicitly declared callback method. In the following example, the cache is pre-populated upon initialization and cleared upon destruction. Public class caching, movie, lister. At post, construct. Public void populate movie cache, / populates the movie cache upon initialization. At pre-destroy. Public void clear movie cache, / clears the movie cache upon destruction. For details about the effects of combining various lifecycle mechanisms, see combining lifecycle mechanisms. Like at resource, the at post construct and at pre-destroy annotation types were a part of the standard Java libraries from JDK 6 to 8. However, the entire javax.annotation package got separated from the core Java modules in JDK 9 and eventually removed in JDK 11. As of Jakarta EE9, the package lives in Jakarta.annotation now. If needed, the Jakarta.annotation API artifact needs to be obtained via Maven Central now, simply to be added to the application's class path like any other library. Classpath scanning and managed components. Most examples in this chapter use XML to specify the configuration metadata that produces each bin definition within the Spring container. The previous section, Annotation-Based Container Configuration, demonstrates how to provide a lot of the configuration metadata through source-level annotations. Even in those examples, however, the base bin definitions are explicitly defined in the XML file, while the annotations drive only the dependency injection. This section describes an option for implicitly detecting the candidate components by scanning the class path. Candidate components are classes that match against a filter criteria and have a corresponding bin definition registered with the container. This removes the need to use XML to perform bin registration. Instead, you can use annotations, for example, at component, aspect type expressions, or your own custom filter criteria to select which classes have bin definitions registered with the container. You can define beans using Java rather than using XML files. Take a look at the configuration, at bin, at import, and it depends on annotations for examples of how to use these features. At component and further stereotype annotations. The at repository annotation is a marker for any class that fulfills the role or stereotype of a repository, also known as Data Access Object or DAO. Among the uses of this marker is the automatic translation of exceptions, as described in exception translation. Spring provides further stereotype annotations, at component, at service, and at controller. At component is a generic stereotype for any Spring managed component. At repository, at service, and at controller are specializations of at component for more specific use cases, in the persistence, service, and presentation layers, respectively. Therefore, you can annotate your component classes with at component, but, by annotating them with at repository, at service, or at controller instead, your classes are more properly suited for processing by tools or associating with aspects. For example, these stereotype annotations make ideal targets for point cuts. At repository, at service, and at controller can also carry additional semantics in future releases of the Spring framework. Thus, if you are choosing between using at component or at service for your service layer, at service is clearly the better choice. Similarly, as stated earlier, at repository is already supported as a marker for automatic exception translation in your persistence layer. Using meta-annotations and composed annotations, many of the annotations provided by Spring can be used as meta-annotations in your own code. A meta-annotation is an annotation that can be applied to another annotation. For example, the at-service annotation mentioned earlier is meta-annotated with at component, as the following example shows. At target element type at retention policy.runtime at documented. At component public at interface service // The at component causes at service to be treated in the same way as at component. You can also combine meta annotations to create composed annotations. For example, the at rest controller annotation from Spring MVC is composed of at controller and at response body. In addition, composed annotations can optionally redeclare attributes from meta annotations to allow customization. This can be particularly useful when you want to only expose a subset of the meta annotation's attributes. For example, Spring's at session scope annotation hard codes the scope name to session but still allows customization of the proxy mode. The following listing shows the definition of the session scope annotation. At target element type, element type.method, at retention policy.runtime at documented. At scope web application context.scope_session, public at interface session, scope /alias 4, at link scope hash proxy mode. P greater than defaults to, at link scoped proxy mode hash target _class. At alias for annotation equals scope.class, scoped proxy mode default scoped proxy mode target _class. You can then use its session scope without declaring the proxy mode as follows. You can also override the value for the proxy mode, as the following example shows. At service. At session scope proxy mode equals scoped proxy mode interfaces, public class session scoped user service implements user service, // For further details, see the Spring Annotation Programming Model Wiki page. Automatically detecting classes and registering bin definitions. Spring can automatically detect stereotyped classes and register corresponding bin definition instances with the application context. For example, the following two classes are eligible for such auto-detection. At service. Public class simple, movie, lister. Private movie finder. Public simple movie lister movie finder. This movie finder equals movie finder. To auto-detect these classes and register the corresponding beans, you need to add a component scan to your @configuration class, where the base package's attribute is a common parent package for the two classes. Alternatively, you can specify a comma or semicolon or space-separated list that includes the parent package of each class. At configuration. At component scan base packages equals org.example, public class @config, // For brevity, the preceding example could have used the value attribute of the annotation, that is, at component scanner org.example. http URL. The use of context component scan implicitly enables the functionality of context annotation config. There is usually no need to include the context annotation config element when using context component scan. The scanning of class path packages requires the presence of corresponding directory entries in the class path. When you build jars with Ant, make sure that you do not activate the files only switch of the jar task. Also, classpath directories may not be exposed based on security policies in some environments. For example, standalone apps on JDK 1.7.0_45 and higher, which requires trusted library setup in your manifest. See stackoverflow.com/1939457/java JRE7 U45 breaks class loader get resources. On JDK 9's module path, Jigsaw, Spring's class path scanning generally works as expected. However, make sure that your component classes are exported in your module info descriptors. If you expect Spring to invoke non-public members of your classes, make sure that they are opened, that is, that they use an opens declaration instead of an exports declaration in your module info descriptor. Furthermore, the auto-wired annotation bin post processor and common annotation bin post processor are both implicitly included when you use the component scan element. That means that the two components are auto-detected and wired together, all without any bin configuration metadata provided in XML. You can disable the registration of auto-wired annotation bin post-processor and common annotation bin post-processor by including the annotation config attribute with a value of false. Using filters to customize scanning. By default, class is annotated with @component, @repository, @service, @controller, @configuration, or a custom annotation that itself is annotated with @component of the only detected candidate components. However, you can modify and extend this behavior by applying custom filters. Add them as include filters or exclude filters attributes of the @component scan annotation, or as context include filter, greater than or context exclude filter, greater than child elements of the context component scan element in XML configuration. Each filter element requires the type and expression attributes. The following table describes the filtering options. Annotation, default. org.example.sum, annotation. An annotation to be present or meta-present at the type level in target components. Assignable. org.example.sum, class. A class, or interface, that the target components are assignable to, extend or implement. Aspect. org.example. Service plus. An aspect type expression to be matched by the target components, regex. org.example.default. A regex expression to be matched by the target components class names. Custom. org.example.my. Type. Filter. A custom implementation of the org.springframework.core.type filter interface. The following example shows the configuration ignoring all @repository annotations and using stub repositories instead. @configuration. @component scan base packages equals org.example, include filters equals @filter type equals filter type.regex, pattern equals. Stub. Repository, exclude filters equals @filter repository.class, public class app config, // You can also disable the default filters by setting use default filters equals false on the annotation or by providing use default filters equals false as an attribute of the component scanner element. This effectively disables automatic detection of classes annotated or meta-annotated with @component, @repository, @service, @controller, @rest controller, or @configuration. Defining bin metadata within components. Spring components can also contribute bin definition metadata to the container. You can do this with the same @bin annotation used to define bin metadata within @configuration annotated classes. The following example shows how to do so. @component. Public class factory, method, component. @bin. @qualifier public test bin public instance, return new test bin public instance. Public void do work, // component method implementation omitted. The preceding class is a Spring component that has application-specific code in its do work method. However, it also contributes a bin definition that has a factory method referring to the method public instance. The @bin annotation identifies the factory method and other bin definition properties, such as a qualifier value through the @qualifier annotation. Other method-level annotations that can be specified are @scope, @lazy, and custom qualifier annotations. In addition to its role for component initialization, you can also place the @lazy annotation on injection points marked with @auto-wired or @inject. In this context, it leads to the injection of a lazy resolution proxy. However, such a proxy approach is rather limited. For sophisticated lazy interactions, in particular in combination with optional dependencies, we recommend object provider myTargetBin instead. Auto-wired fields and methods are supported, as previously discussed, with additional support for auto-wiring of @bin methods. The following example shows how to do so. @component. Public class factory, method, component. Private static int I. @bin. @qualifier public test bin public instance, return new test bin public instance. // use of a custom qualifier and auto-wiring of method parameters. @bin. Protected test bin protected instance @qualifier public test bin spouse @value #private instance.age, string country, Test bin tb equals new test bin protected instance, 1, tb.set spouse spouse, tb.set country country, return tb. At bin. Private test bin private instance, return new test bin private instance, I++. At bin. At request scope. Public test bin request scoped instance, return new test bin request scoped instance, 3. The example auto-wires the string method parameter country to the value of the age property on another bin named private instance. A Spring expression language element defines the value of the property through the notation hash expression. For @value annotations, an expression resolver is preconfigured to look for bin names when resolving expression text. As of Spring Framework 4.3, you may also declare a factory method parameter of type injection point, or its more specific subclass, dependency descriptor, to access the requesting injection point that triggers the creation of the current bin. Note that this applies only to the actual creation of bin instances, not to the injection of existing instances. As a consequence, this feature makes most sense for beans of prototype scope. For other scopes, the factory method only ever sees the injection point that triggered the creation of a new bin instance in the given scope, for example, the dependency that triggered the creation of a lazy singleton bin. You can use the provided injection point metadata with semantic care in such scenarios. The following example shows how to use injection point. At component. Public class factory, method, component. At bin at scope prototype, public test bin prototype instance injection point. Return new test bin prototype instance for plus injection. Point.get, member. The @bin methods in a regular Spring component are processed differently than their counterparts inside a Spring @configuration class. The difference is that @component classes are not enhanced with glib to intercept the invocation of methods and fields. Glib proxying is the means by which invoking methods or fields within @bin methods in @configuration classes creates bin metadata references to collaborating objects. Such methods are not invoked with normal Java semantics but rather go through the container in order to provide the usual lifecycle management and proxying of Spring beans, even when referring to other beans through programmatic calls to @bin methods. In contrast, invoking a method or field in a @bin method within a plain @component class has standard Java semantics, with no special glib processing or other constraints applying. You may declare @bin methods as static, allowing for them to be called without creating their containing configuration class as an instance. This makes particular sense when defining post-processor beans, for example, of type bin factory post-processor or bin post-processor, since such beans get initialized early in the container lifecycle and should avoid triggering other parts of the configuration at that point. Calls to static @bin methods never get intercepted by the container, not even within configuration classes, as described earlier in this section. Due to technical limitations, glib subclassing can override only non-static methods. As a consequence, a direct call to another @bin method has standard Java semantics, resulting in an independent instance being returned straight from the factory method itself. The Java language visibility of @bin methods does not have an immediate impact on the resulting bin definition in Spring's container. You can freely declare your factory methods as you see fit in non-configuration classes and also for static methods anywhere. However, regular @bin methods in configuration classes need to be overridable, that is, they must not be declared as private or final. @bin methods are also discovered on base classes of a given component or configuration class, as well as on Java 8 default methods declared in interfaces implemented by the component or configuration class. This allows for a lot of flexibility in composing complex configuration arrangements, with even multiple inheritance being possible through Java 8 default methods as of Spring 4.2. Finally, a single class may hold multiple @bin methods for the same bin, as an arrangement of multiple factory methods to use depending on available dependencies at runtime. This is the same algorithm as for choosing the greediest constructor or factory method in other configuration scenarios. The variant with the largest number of satisfiable dependencies is picked at construction time, analogous to how the container selects between multiple auto-wired constructors. Naming auto-detected components. When a component is auto-detected as part of the scanning process, its bin name is generated by the bin name generator strategy known to that scanner. By default, any Spring stereotype annotation, @component, @repository, @service, and @controller, that contains a name value thereby provides that name to the corresponding bin definition. If such an annotation contains no name value or for any other detected component, such as those discovered by custom filters, the default bin name generator returns the uncapitalized non-qualified class name. For example, if the following component classes were detected, the names would be My Movie Lister and Movie Finder, Impl. If you do not want to rely on the default bin naming strategy, you can provide a custom bin naming strategy. First, implement the bin name generator interface, and be sure to include a default no-arg constructor. Then, provide the fully qualified class name when configuring the scanner, as the following example annotation and bin definition show. If you run into naming conflicts due to multiple auto-detected components having the same non-qualified class name, i.e., classes with identical names but residing in different packages, you may need to configure a bin name generator that defaults to the fully qualified class name for the generated bin name. As of Spring Framework 5.2.3, the fully qualified annotation bin name generator located in package org.springframework.context.annotation can be used for such purposes. @configuration. @component scan base packages equals org.example, name generator equals my name generator.class, public class app config, // As a general rule, consider specifying the name with the annotation whenever other components may be making explicit references to it. On the other hand, the auto-generated names are adequate whenever the container is responsible for wiring. Providing a scope for auto-detected components. As with Spring managed components in general, the default and most common scope for auto-detected components is singleton. However, sometimes you need a different scope that can be specified by the @scope annotation. You can provide the name of the scope within the annotation, as the following example shows. @scope annotations are only introspected on the concrete bin class, for annotated components, or the factory method, for @bin methods. In contrast to XML bin definitions, there is no notion of bin definition inheritance, and inheritance hierarchies at the class level are irrelevant for metadata purposes. For details on web-specific scopes such as request or session in a Spring context, see request, session, application, and WebSocket scopes. As with the pre-built annotations for those scopes, you may also compose your own scoping annotations by using Spring's meta-annotation approach, for example, a custom annotation meta-annotated with its scope prototype, possibly also declaring a custom scoped proxy mode. To provide a custom strategy for scope resolution rather than relying on the annotation-based approach, you can implement the Scope Metadata Resolver interface. Be sure to include a default no-arg constructor. Then you can provide the fully qualified class name when configuring the scanner, as the following example of both an annotation and a bin definition shows. @configuration. @component scan base packages equals org.example, scope resolver equals my scope resolver.class, public class app config, // When using certain non-singleton scopes, it may be necessary to generate proxies for the scoped objects. The reasoning is described in scoped beans as dependencies. For this purpose, a scoped proxy attribute is available on the component scanner element. The three possible values are no, interfaces, and target class. For example, the following configuration results in standard JDK dynamic proxies. @configuration. @component scan base packages equals org.example, scoped proxy equals scoped proxy mode.interfaces, public class app config, // Providing qualifier metadata with annotations. The @qualifier annotation is discussed in fine-tuning annotation-based auto-wiring with qualifiers. The examples in that section demonstrate the use of the @qualifier annotation and custom qualifier annotations to provide fine-grained control when you resolve auto-wire candidates. Because those examples were based on XML bin definitions, The qualifier metadata was provided on the candidate bin definitions by using the qualifier or meta-child elements of the bin element in the XML. When relying upon class-path scanning for auto-detection of components, you can provide the qualifier metadata with type-level annotations on the candidate class. The following 3 examples demonstrate this technique. As with most annotation-based alternatives, keep in mind that the annotation metadata is bound to the class definition itself, while the use of XML allows for multiple beans of the same type to provide variations in their qualifier metadata, because that metadata is provided per instance rather than per class. Generating an index of candidate components. While class-path scanning is very fast, it is possible to improve the startup performance of large applications by creating a static list of candidates at compilation time. In this mode, all modules that are targets of component scanning must use this mechanism. Your existing component scan or context component scan directives must remain unchanged to request the context to scan candidates in certain packages. When the application context detects such an index, it automatically uses it rather than scanning the class path. To generate the index, add an additional dependency to each module that contains components that are targets for component scan directives. The following example shows how to do so with Maven. Dependencies dependency groupid org.spring framework /groupid artifacted spring context indexer /artifacted version greater than 6.0.12 version optional true optional dependencies. With Gradle 4.5 and earlier, the dependency should be declared in the compile-only configuration, as shown in the following example. Dependencies compile-only org.spring framework spring context indexer :6.0.12. With Gradle 4.6 and later, the dependency should be declared in the annotation processor configuration, as shown in the following example. Dependencies annotation processor org.spring framework spring context indexer :6.0.12. The Spring Context Indexer artifact generates a meta-inf/spring.components file that is included in the jar file. When working with this mode in your IDE, the Spring Context Indexer must be registered as an annotation processor to make sure the index is up to date when candidate components are updated. The index is enabled automatically when a meta-inf/spring.components file is found on the class path. If an index is partially available for some libraries or use cases, but could not be built for the whole application, you can fall back to a regular class path arrangement, as though no index were present at all, by setting spring.index.ignore to true, either as a JVM system property or via the Spring Properties mechanism. Using JSR 330 standard annotations, Spring offers support for JSR 330 standard annotations, dependency injection. Those annotations are scanned in the same way as the Spring annotations. To use them, you need to have the relevant jars in your class path. If you use Maven, the Jakarta.inject artifact is available in the standard Maven repository, http URL. You can add the following dependency to your file pom.xml. Dependency groupid jakarta.inject/groupid artifacted jakarta.inject API/artifacted version greater than 2.0.0 version dependency. Dependency injection with @inject and @named. Instead of @autowired, you can use jakarta.inject.inject as follows. Public class simple, movie, lister. Private movie finder @inject. Public void set movie finder. This.movie finder equals movie finder. Public void list movies. This.movie finder.find movies // As with @autowired, you can use @inject at the field level, method level and constructor argument level. Furthermore, you may declare your injection point as a provider, allowing for on-demand access to beans of shorter scopes or lazy access to other beans through a provider.get call. The following example offers a variant of the preceding example. Import Jakarta.inject.inject, import Jakarta.inject.provider. Public class simple, movie, lister. Private provider movie finder. At inject. Public void set movie finder provider movie finder. This.movie finder equals movie finder. Public void list movies, this.movie finder.get. Find movies, // If you would like to use a qualified name for the dependency that should be injected, you should use the @named annotation, as the following example shows. Import Jakarta.inject.inject, import Jakarta.inject.named. Public class simple, movie, lister. Private movie finder. At inject. Public void set movie finder at named main, movie finder. This.movie finder equals movie finder. // As with @autowired, at inject can also be used with java.util.optional or @nullable. This is even more applicable here, since at inject does not have a required attribute. The following pair of examples show how to use at inject and @nullable. Public class simple, movie, lister. At inject. Public void set movie finder optional movie finder, // Public class simple, movie, lister. At inject. Public void set movie finder @nullable movie finder, // At named and @managed bin, standard equivalents to the @component annotation. Instead of @component, you can use Jakarta.inject.named or Jakarta.annotation.managed bin, as the following example shows. Import Jakarta.inject.inject, import Jakarta.inject.named. At named movie listener, // at managed bin movie listener, could be used as well. Public class simple, movie, lister. Private movie finder. At inject. Public void set movie finder. This.movie finder equals movie finder. // It is very common to use @component without specifying a name for the component. @named can be used in a similar fashion, as the following example shows. Import Jakarta.inject.inject, import Jakarta.inject.named. At named. Public class simple, movie, lister. Private movie finder. At inject. Public void set movie finder. This.movie finder equals movie finder. // When you use @named or @managed bin, you can use component scanning in the exact same way as when you use Spring annotations, as the following example shows. At configuration. At component scan base packages equals org.example, public class @config, // In contrast to @component, the JSR 330 @named and the JSR 250 @managed bin annotations are not composable. You should use Spring's stereotype model for building custom component annotations. Limitations of JSR 330 standard annotations. When you work with standard annotations, you should know that some significant features are not available, as the following table shows. Table 1. Spring component model elements versus JSR 330 variants. At autowired. At inject. At inject has no required attribute. Can be used with Java 8's optional instead. At component. At named, at managed, bin. JSR 330 does not provide a composable model, only a way to identify named components. At scope singleton. At singleton. The JSR 330 default scope is like Spring's prototype. However, in order to keep it consistent with Spring's general defaults, a JSR 330 bin declared in the Spring container is a singleton by default. In order to use a scope other than singleton, you should use Spring's @scope annotation. Jakarta.inject also provides a Jakarta.inject.scope annotation, however, this one is only intended to be used for creating custom annotations. At qualifier. At qualifier, at named. Jakarta.inject.qualifier is just a meta-annotation for building custom qualifiers. Concrete string qualifiers, like springs at qualifier with a value, can be associated through Jakarta.inject.named. At value. No equivalent. At lazy. No equivalent. Object. Factory. Provider. Jakarta.inject.provider is a direct alternative to Spring's object factory, only with a shorter get method name. It can also be used in combination with springs at auto-wired or with non-annotated constructors and setter methods. Java-based container configuration. This section covers how to use annotations in your Java code to configure the Spring container. It includes the following topics. 1. Basic concepts, at bin and at configuration. 2. Instantiating the Spring container by using annotation config application context. 3. Using the at bin annotation. 4. Using the at configuration annotation. 5. Composing Java-based configurations. 6. Bin definition profiles. 7. Property source abstraction. 8. Using at property source. 9. Placeholder resolution in statements. Basic concepts, at bin and at configuration. The central artifacts in Spring's Java configuration support are at configuration annotated classes and at bin annotated methods. The at bin annotation is used to indicate that a method instantiates, configures, and initializes a new object to be managed by the Spring IoC container. For those familiar with Spring's Beans XML configuration, the at bin annotation plays the same role as the bin element. You can use at bin annotated methods with any Spring at component. However, they are most often used with at configuration beans. Annotating a class with at configuration indicates that its primary purpose is as a source of bin definitions. Furthermore, at configuration classes let inter-bin dependencies be defined by calling other at bin methods in the same class. The simplest possible at configuration class reads as follows. At configuration. Public class app, config. At bin. Public myService impl myService, return new myService, impl. The preceding app config class is equivalent to the following Spring Beans XML. When at bin methods are declared within classes that are not annotated with at configuration, they are referred to as being processed in a light mode. Bin methods declared in a at component or even in a plain old class are considered to be light, with a different primary purpose of the containing class and a at bin method being a sort of bonus there. For example, service components may expose management views to the container through an additional at bin method on each applicable component class. In such scenarios, at bin methods are a general-purpose factory method mechanism. Unlike full at configuration, light at bin methods cannot declare inter-bin dependencies. Instead, they operate on their containing components' internal state and, optionally, on arguments that they may declare. Such a at bin method should therefore not invoke other at bin methods. Each such method is literally only a factory method for a particular bin reference, without any special runtime semantics. The positive side effect here is that no CLIB subclassing has to be applied at runtime, so there are no limitations in terms of class design, that is, the containing class may be final and so forth. In common scenarios, at bin methods are to be declared within at configuration classes, ensuring that full mode is always used and that cross-method references therefore get redirected to the container's lifecycle management. This prevents the same at bin method from accidentally being invoked through a regular Java call, which helps to reduce subtle bugs that can be hard to track down when operating in light mode. The at bin and at configuration annotations are discussed in depth in the following sections. First, however, we cover the various ways of creating a Spring container by using Java-based configuration. Instantiating the Spring container by using annotation config application context. The following sections document Spring's annotation config application context, introduced in Spring 3.0. This versatile application context implementation is capable of accepting not only at configuration classes as input but also plain at component classes and classes annotated with JSR 330 metadata. When at configuration classes are provided as input, the at configuration class itself is registered as a bin definition and all declared at bin methods within the class are also registered as bin definitions. When at component and JSR 330 classes are provided, they are registered as bin definitions, and it is assumed that DI metadata such as at autowired or at inject are used within those classes where necessary. Simple construction. In much the same way that Spring XML files are used as input when instantiating a class path XML application context, you can use at configuration classes as input when instantiating an annotation config application context. This allows for completely XML-free usage of the Spring container, as the following example shows. Public static void main string, args. Application context CTX equals new annotation config application context app config.class, my service equals ctx.getBin my service.class, my service.do, stuff. As mentioned earlier, annotation config application context is not limited to working only with at configuration classes. Any at component or JSR 330 annotated class may be supplied as input to the constructor, as the following example shows. Public static void main string, args. Application context CTX equals new annotation config application context my service impl.class, dependency1.class, dependency2.class, my service equals ctx.getBin my service.class, my service.do, stuff. The preceding example assumes that my service impl, dependency1, and dependency2 use Spring dependency injection annotations such as at autowired. Building the container programmatically by using register class less than greater than dot, you can instantiate an annotation config application context by using a no-arg constructor and then configure it by using the register method. This approach is particularly useful when programmatically building an annotation config application context. The following example shows how to do so. Public static void main string, args. Annotation config application context CTX equals new annotation config application context, ctx.register app config.class, other config.class, ctx.register additional config.class, ctx.refresh, my service equals ctx.getBin my service.class, my service.do, stuff. Enabling component scanning with scan string. To enable component scanning, you can annotate your at configuration class as follows. At configuration. At component scan base packages equals com.acme, public class app config, // Experienced Spring users may be familiar with the XML declaration equivalent from Spring's context, namespace, shown in the following example. In the preceding example, the com.acme package is scanned to look for any at component annotated classes, and those classes are registered as Spring bin definitions within the container. Annotation config application context exposes the scan string method to allow for the same component scanning functionality, as the following example shows. Public static void main string, args. Annotation config application context CTX equals new annotation config application context, ctx.scancom.acme, ctx.refresh, my service equals ctx.getBin my service.class. Remember that at configuration classes are meta-annotated with at component, so they are candidates for component scanning. In the preceding example, assuming that app config is declared within the com.acme package, or any package underneath, it is picked up during the call to scan. Upon refresh, all its at bin methods are processed and registered as bin definitions within the container. Support for web applications with annotation config web application context, A web application context variant of annotation config application context is available with annotation config web application context. You can use this implementation when configuring the Spring Context Loader Listener Servlet Listener, Spring MVC Dispatcher Servlet, and so forth. The following web.xml snippet configures a typical Spring MVC web application. Note the use of the context class context param and init param. Web app configure context loader listener to use annotation config web application context. Instead of the default XML web application context, greater than context param name context class /param name param value org.springframework.web.context.support.annotation config web application context /param value /context param less than. Configuration locations must consist of one or more comma or space delimited. Fully qualified at configuration classes. Fully qualified packages may also be specified for component scanning, greater than context param name context config location /param name param value com.acme.app config /param value /context param. Less than. Bootstrap the root application context as usual using context loader listener, greater than listener class org.springframework.web.context loader listener /listener class /listener. Less than, declare a Spring MVC dispatcher servlet as usual, greater than servlet name dispatcher /servlet name servlet class org.springframework.web.servlet.dispatcher servlet /servlet class less than. Configure dispatcher servlet to use annotation config web application context. Instead of the default XML web application context, greater than init param name context class /param name param value org.springframework.web.context.support.annotation config web application context /param value /init param less than. Again, config locations must consist of one or more comma or space delimited, and fully qualified at configuration classes, greater than init param name context config location /param name param value com.acme.web.mvc config /param value /init param /servlet. Less than, map all requests for /app/ to the dispatcher servlet, greater than servlet mapping servlet name dispatcher /servlet name less than URL pattern /app/ less than URL pattern /servlet mapping /web app. For programmatic use cases, a generic web application context can be used as an alternative to annotation config web application context. See the generic web application context Javadoc for details. Using the @bin annotation. @bin is a method-level annotation and a direct analog of the XML bin element. The annotation supports some of the attributes offered by bins such as: you can use the @bin annotation in a configuration annotated or in a component annotated class. Declaring a bin. To declare a bin, you can annotate a method with the @bin annotation. You use this method to register a bin definition within an application context of the type specified as the method's return value. By default, the bin name is the same as the method name. The following example shows a @bin method declaration. @configuration. Public class app. Config. @bin. Public transfer service impl transfer service, return new transfer. Service. Impl. The preceding configuration is exactly equivalent to the following Spring XML. Both declarations make a bin named transfer service available in the application context, bound to an object instance of type transfer service impl, as the following text image shows. You can also use default methods to define bins. This allows composition of bin configurations by implementing interfaces with bin definitions on default methods. Public interface base. Config. @bin. Default transfer service impl transfer service, return new transfer. Service. Impl. @configuration. Public class app config implements base. Config. You can also declare your @bin method with an interface, or base class, return type, as the following example shows. At configuration. Public class app, config. At bin. Public transfer service, return new transfer, service, impl. However, this limits the visibility for advanced type prediction to the specified interface type, transfer service. Then, with the full type, transfer service impl, known to the container only once the affected singleton bin has been instantiated. Non-lazy singleton beans get instantiated according to their declaration order, so you may see different type matching results depending on when another component tries to match by a non-declared type, such as at auto-wired transfer service impl, which resolves only once the transfer service bin has been instantiated. If you consistently refer to your types by a declared service interface, your bin return types may safely join that design decision. However, for components that implement several interfaces or for components potentially referred to by their implementation type, it is safer to declare the most specific return type possible, at least as specific as required by the injection points that refer to your bin. Bin dependencies. A bin annotated method can have an arbitrary number of parameters that describe the dependencies required to build that bin. For instance, if our transfer service requires an account repository, we can materialize the dependency with a method parameter, as the following example shows. At configuration. Public class app, config. At bin. Public transfer service account repository. Return new transfer service impl account, repository. The resolution mechanism is pretty much identical to constructor-based dependency injection. See the relevant section for more details. Receiving lifecycle callbacks. Any classes defined with the @bin annotation support the regular lifecycle callbacks and can use the @post construct and @predestroy annotations from JSR 250. See JSR 250 annotations for further details. The regular Spring lifecycle callbacks are fully supported as well. If a bin implements initializing bin, disposable bin, or lifecycle, their respective methods are called by the container. The standard set of aware interfaces, such as bin factory aware, bin name aware, message source aware, application context aware, and so on, are also fully supported. The @bin annotation supports specifying arbitrary initialization and destruction callback methods, much like Spring XML's init method and destroy method attributes on the bin element, as the following example shows. Public class bin 1. Public void init / initialization logic. Public class bin 2. Public void cleanup / destruction logic. At configuration. Public class app, config. At bin init method equals init, public bin 1, return new bin 1. At bin destroy method equals cleanup, public bin 2, return new bin 2. By default, beans defined with Java configuration that have a public close or shutdown method are automatically enlisted with a destruction callback. If you have a public close or shutdown method and you do not wish for it to be called when the container shuts down, you can add @bin destroy method equals to your bin definition to disable the default inferred mode. You may want to do that by default for a resource that you acquire with JNDI, as its lifecycle is managed outside the application. In particular, make sure to always do it for a data source, as it is known to be problematic on Jakarta EE application servers. The following example shows how to prevent an automatic destruction callback for a data source. At bin destroy method equals public data source throws naming exception, return data source JND template.lookupMyDs. Also, with @bin methods, you typically use programmatic JNDI lookups, either by using Spring's JND template or JND locator delegate helpers or straight JNDI initial context usage, but not the JND object factory bin variant, which would force you to declare the return type as the factory bin type instead of the actual target type, making it harder to use for cross-reference calls in other @bin methods that intend to refer to the provided resource here. In the case of bin 1 from the example above the preceding note, it would be equally valid to call the init method directly during construction, as the following example shows. At configuration. Public class app, config. At bin. Public bin1 bin1, bin1 bin1 equals new bin1, bin1.init, return bin1. // When you work directly in Java, you can do anything you like with your objects and do not always need to rely on the container lifecycle. Specifying bin scope. Spring includes the @scope annotation so that you can specify the scope of a bin. Using the @scope annotation, you can specify that your beans defined with the @bin annotation should have a specific scope. You can use any of the standard scopes specified in the bin scope section. The default scope is singleton, but you can override this with the @scope annotation, as the following example shows. @configuration. Public class my configuration. @bin. @scope prototype, public encryptor // @scope and scoped proxy. Spring offers a convenient way of working with scoped dependencies through scoped proxies. The easiest way to create such a proxy when using the XML configuration is the AOP scoped proxy element. Configuring your beans in Java with @scope annotation offers equivalent support with the proxy mode attribute. The default is scoped proxy mode.default, which typically indicates that no scoped proxy should be created unless a different default has been configured at the component scan instruction level. You can specify scoped proxy mode.target_class, scoped proxy mode.interfaces or scoped proxy mode.no. If you port the scoped proxy example from the XML reference documentation, see scoped proxies, to our bin using Java, it resembles the following. // an HTTP session scoped and exposed as a proxy. @bin. @session scope. Public user preferences, return new user preferences. @bin. Public service service equals new simple user service, // a reference to the proxied user preferences bin. Service.set user preferences, return service. Customizing bin naming. By default, configuration classes use @bin method's name as the name of the resulting bin. This functionality can be overridden, however, with the name attribute, as the following example shows. @configuration. Public class app, config. @bin my thing, public thing, return new thing. Bin aliasing. As discussed in naming beans, it is sometimes desirable to give a single bin multiple names, otherwise known as bin aliasing. The name attribute of the @bin annotation accepts a string array for this purpose. The following example shows how to set a number of aliases for a bin. @configuration. Public class app, config. @bin data source, subsystem a data source, subsystem data source, public data source // instantiate, configure and return data source bin. Bin description. Sometimes, it is helpful to provide a more detailed textual description of a bin. This can be particularly useful when beans are exposed, perhaps through JMX, for monitoring purposes. To add a description to @bin, you can use the @description annotation, as the following example shows. @configuration. Public class app, config. @bin. @description provides a basic example of a bin, public thing, return new thing. Using the @configuration annotation. @configuration is a class-level annotation indicating that an object is a source of bin definitions. @configuration classes declare beans through @bin annotated methods. Calls to @bin methods on @configuration classes can also be used to define inter-bin dependencies. See basic concepts, @bin and @configuration for a general introduction. Injecting inter-bin dependencies. When beans have dependencies on one another, expressing that dependency is as simple as having one bin method call another, as the following example shows. @configuration. Public class app, config. @bin. Public bin1, return new bin1 bin2. @bin. Public bin2, return new bin2. In the preceding example, bin1 receives a reference to bin2 through constructor injection. This method of declaring inter-bin dependencies works only when the @bin method is declared within a @configuration class. You cannot declare inter-bin dependencies by using plain @component classes. Lookup method injection. As noted earlier, lookup method injection is an advanced feature that you should use rarely. It is useful in cases where a singleton scoped bin has a dependency on a prototype scoped bin. Using Java for this type of configuration provides a natural means for implementing this pattern. The following example shows how to use lookup method injection. Public abstract class command manager, public object process object command state, // grab a new instance of the appropriate command interface. Command equals create command, / set the state on the, hopefully brand new, command instance. Command.set state command state, return command.execute. / OK. But where is the implementation of this method? Protected abstract command create command. By using Java configuration, you can create a subclass of command manager where the abstract create command method is overridden in such a way that it looks up a new, prototype, command object. The following example shows how to do so. @bin. @scope prototype, public async command command equals new async command, // inject dependencies here as required. Return command. @bin. Public command manager / return new anonymous implementation of command manager with create command / overridden to return a new prototype command object. Return new command manager, protected command create command, return async command. Further information about how Java-based configuration works internally. Consider the following example, which shows a @bin annotated method being called twice. @configuration. Public class app, config. @bin. Public client service 1, client service impl client service equals new client service impl, client service.set client DAO, return client, service. @bin. Public client service 2, client service impl client service equals new client service impl, client service.set client DAO, return client, service. @bin. Public client DAO, return new client, DAO, impl. Client DAO has been called once in client service 1 and once in client service 2. Since this method creates a new instance of client DAO impl and returns it, you would normally expect to have two instances, one for each service. That definitely would be problematic. In Spring, instantiated beans have a singleton scope by default. This is where the magic comes in. All configuration classes are subclassed at startup time with clib. In the subclass, the child method checks the container first for any cached, scoped, beans before it calls the parent method and creates a new instance. The behavior could be different according to the scope of your bin. We are talking about singletons here. It is not necessary to add clib to your class path because clib classes are repackaged under the org.springframework.clib package and included directly within the Spring core jar. There are a few restrictions due to the fact that clib dynamically adds features at startup time. In particular, configuration classes must not be final. However, any constructors are allowed on configuration classes, including the use of auto-wired or a single non-default constructor declaration for default injection. If you prefer to avoid any clib-imposed limitations, consider declaring your @bin methods on non-configuration classes, for example, on plain component classes instead, or by annotating your configuration class with configuration proxy bin methods equals false. Cross-method calls between bin methods are then not intercepted, so you have to exclusively rely on dependency injection at the constructor or method level there. Composing Java-based configurations. Spring's Java-based configuration feature lets you compose annotations, which can reduce the complexity of your configuration. Using the @import annotation, Much as the import element is used within Spring XML files to aid in modularizing configurations, the @import annotation allows for loading @bin definitions from another configuration class, as the following example shows. @configuration. Public class configure. @bin. Public AA, return new A. @configuration. @import configure.class public class config. @bin. Public BB, return new B. Now, rather than needing to specify both configure.class and config.class when instantiating the context, only config needs to be supplied explicitly, as the following example shows. Public static void main string, args. Application context CTX equals new annotation config application context config.class. // now both beans A and B will be available. A equals ctx.getBinA.class, BB equals ctx.getBinB.class. This approach simplifies container instantiation, as only one class needs to be dealt with, rather than requiring you to remember a potentially large number of configuration classes during construction. As of Spring Framework 4.2, @import also supports references to regular component classes, analogous to the annotation config application context.register method. This is particularly useful if you want to avoid component scanning, by using a few configuration classes as entry points to explicitly define all your components. Injecting dependencies on imported @bin definitions. The preceding example works but is simplistic. In most practical scenarios, beans have dependencies on one another across configuration classes. When using XML, this is not an issue, because no compiler is involved, and you can declare ref equals some bin and trust Spring to work it out during container initialization. When using configuration classes, the Java compiler places constraints on the configuration model, in that references to other beans must be valid Java syntax. Fortunately, solving this problem is simple. As we already discussed, a @bin method can have an arbitrary number of parameters that describe the bin dependencies. Consider the following more real-world scenario with several configuration classes, each depending on beans declared in the others. @configuration. Public class service, config. @bin. Public transfer service account repository, return new transfer service impl account, repository. @configuration. Public class repository, config. @bin. Public account repository data source, return new JDBC account repository data, source. @configuration. @import service config.class, repository config.class, public class system, test, config. @bin. Public data source / return new data, source. Public static void main string, args. Application context CTX equals new annotation config application context system test config.class / everything wires up across configuration classes. Transfer service equals ctx.getBin transfer service.class transfer service.transfer 100.00 A123 C456. There is another way to achieve the same result. Remember that configuration classes are ultimately only another bin in the container. This means that they can take advantage of auto-wired and value injection and other features the same as any other bin. Make sure that the dependencies you inject that way are of the simplest kind only. Configuration classes are processed quite early during the initialization of the context, and forcing a dependency to be injected this way may lead to unexpected early initialization. Whenever possible, resort to parameter-based injection, as in the preceding example. Also, be particularly careful with bin post-processor and bin factory post-processor definitions through @bin. Those should usually be declared as static @bin methods, not triggering the instantiation of their containing configuration class. Otherwise, @auto-wired and @value may not work on the configuration class itself, since it is possible to create it as a bin instance earlier than auto-wired. Annotation, bin, post, processor. The following example shows how one bin can be auto-wired to another bin. At configuration. Public class service, config. At auto-wired. Private account repository, repository. At bin. Public transfer service, return new transfer service impl account, repository. At configuration. Public class repository, config. Private final data, source. Public repository config data source. This.data source equals data, source. At bin. Public account repository, return new JDBC account repository data, source. At configuration. At import service config.class, repository config.class, public class system, test, config. At bin. Public data source, / return new data, source. Public static void main string, args. Application context CTX equals new annotation config application context system test config.class, / everything wires up across configuration classes. Transfer service equals ctx.getBin transfer service.class, transfer service.transfer 100.00, A123, C456. Constructor injection init configuration classes is only supported as of Spring Framework 4.3. Note also that there is no need to specify it auto-wired if the target bin defines only one constructor. Fully qualifying imported beans for ease of navigation. In the preceding scenario, using it auto-wired works well and provides the desired modularity, but determining exactly where the auto-wired bin definitions are declared is still somewhat ambiguous. For example, as a developer looking at service config, how do you know exactly where the auto-wired account repository bin is declared? It is not explicit in the code, and this may be just fine. Remember that the Spring Tools for Eclipse provides tooling that can render graphs showing how everything is wired, which may be all you need. Also, your Java IDE can easily find all declarations and uses of the account repository type and quickly show you the location of bin methods that return that type. In cases where this ambiguity is not acceptable and you wish to have direct navigation from within your IDE from one configuration class to another, consider auto-wiring the configuration classes themselves. The following example shows how to do so. At configuration. Public class service, config. At auto-wired. Private repository config repository, config. At bin. Public transfer service, / navigate through the config class to the @bin method. Return new transfer service impl repository, config.account, repository. In the preceding situation, where account repository is defined is completely explicit. However, service config is now tightly coupled to repository config. That is the trade-off. This tight coupling can be somewhat mitigated by using interface-based or abstract class-based configuration classes. Consider the following example. At configuration. Public class service, config. At auto-wired. Private repository config repository, config. At bin. Public transfer service, return new transfer service impl repository, config.account, repository. At configuration. Public interface repository, config. At bin. Account repository, repository. At configuration. Public class default repository config implements repository, config. At bin. Public account repository, return new JDBC, account, repository. At configuration. At import service config.class, default repository config.class, / import the concrete config. Public class system, test, config. At bin. Public data source, / return data, source. Public static void main string, args. Application context CTX equals new annotation config application context system test config.class, transfer service equals ctx.getBin transfer service.class, transfer service.transfer 100.00, A123, C456. Now service config is loosely coupled with respect to the concrete default repository config, and built-in IDE tooling is still useful. You can easily get a type hierarchy of repository config implementations. In this way, navigating at configuration classes and their dependencies becomes no different than the usual process of navigating interface-based code. If you want to influence the startup creation order of certain beans, consider declaring some of them as at lazy, for creation on first access instead of on startup, or as it depends on certain other beans, making sure that specific other beans are created before the current bin, beyond what the latter's direct dependencies imply. Conditionally include at configuration classes or at bin methods. It is often useful to conditionally enable or disable a complete at configuration class or even individual at bin methods, based on some arbitrary system state. One common example of this is to use the at profile annotation to activate beans only when a specific profile has been enabled in the Spring environment. See bin definition profiles for details. The at profile annotation is actually implemented by using a much more flexible annotation called at conditional. The at conditional annotation indicates specific org.springframework.context.annotation.condition implementations that should be consulted before a at bin is registered. Implementations of the condition interface provide a matches method that returns true or false. For example, the following listing shows the actual condition implementation used for at profile. At override. Public Boolean matches condition context annotated type metadata / read the at profile annotation attributes. Multi-value map string object ads equals metadata.get all annotation attributes profile.class.get name if ads equals null. 4. Object value ads.get value if context.get environment accepts profile string value. Return true. Return false. Return true. Combining Java and XML configuration, Spring's at configuration class support does not aim to be a 100% complete replacement for Spring XML. Some facilities, such as Spring XML namespaces, remain an ideal way to configure the container. In cases where XML is convenient or necessary, you have a choice. Either instantiate the container in an XML-centric way by using, for example, class path XML application context, or instantiate it in a Java-centric way by using annotation config application context and the at import resource annotation to import XML as needed. XML-centric use of at configuration classes. It may be preferable to bootstrap the Spring container from XML and include at configuration classes in an ad hoc fashion. For example, in a large existing codebase that uses Spring XML, it is easier to create at configuration classes on an as-needed basis and include them from the existing XML files. Later in this section, we cover the options for using at configuration classes in this kind of XML-centric situation. Declaring at configuration classes as plain Spring bin elements. Remember that at configuration classes are ultimately bin definitions in the container. In this series examples, we create a at configuration class named @config and include it within system-test-config.xml as a bin definition. Because context annotation config is switched on, the container recognizes the at configuration annotation and processes the at bin methods declared in @config properly. The following example shows an ordinary configuration class in Java. At configuration. Public class app. Config. At auto-wired. Private data, source, at bin. Public account repository, return new JDBC account repository data, source. At bin. Public transfer service, return new transfer service account, repository. The following example shows part of a sample system test-config.xml file. Less than. Enable processing of annotations such as at auto-wired and at configuration, greater than. org.springframework.jdbc.datasource.driver, manager, data, source. The following example shows a possible jdbc.properties file. jdbc.url equals jdbc hsqldb hsql://localhost/xdb. jdbc.username equals sar. jdbc.password equals public static void main string, args. Application context ctx equals new class path xml application context class path :com/acme/system test config.xml transfer service equals ctx.getBin transfer service.class // In system test config.xml file, the app config bin does not declare an ID element. While it would be acceptable to do so, it is unnecessary, given that no other bin ever refers to it, and it is unlikely to be explicitly fetched from the container by name. Similarly, the data source bin is only ever auto-wired by type, so an explicit bin ID is not strictly required. Using context component scan to pick up at configuration classes, because at configuration is meta-annotated with at component, at configuration annotated classes are automatically candidates for component scanning. Using the same scenario as described in the previous example, we can redefine system test config.xml to take advantage of component scanning. Note that, in this case, we need not explicitly declare context annotation config because context component scan enables the same functionality. The following example shows the modified system test config.xml file. Picks up and registers app config as a bin definition, greater than org.springframework.jdbc.datasource.driver, manager, data, source. At configuration class-centric use of XML with at import resource. In applications where at configuration classes are the primary mechanism for configuring the container, it is still likely necessary to use at least some XML. In these scenarios, you can use at import resource and define only as much XML as you need. Doing so achieves a Java-centric approach to configuring the container and keeps XML to a bare minimum. The following example, which includes a configuration class, an XML file that defines a bin, a properties file, and the main class, shows how to use the at import resource annotation to achieve Java-centric configuration that uses XML as needed. At configuration. At import resource class path :com/acme/properties config.xml, public class app, config. At value $jdbc.url, private string URL. At value $jdbc.username, private string username. At value $jdbc.password, private string password. At bin. Public data source, return new driver manager data source URL, username, password. Properties config.xml. Beans context property placeholder location equals class path :com/acme/jdbc.properties greater than /beans. jdbc.properties. jdbc.url equals jdbc hsqldb hsql://localhost/xdb. jdbc.username equals sar. jdbc.password equals public static void main string, args. Application context ctx equals new annotation config application context app config.class, transfer service equals ctx.getBin transfer service.class, //